Hello guys, welcome to this YouTube channel Engineering Civil Academy. Today we are going to discuss one important concept, that is incompressibility of water, which is important concept in your fluid mechanics. So for that we will discuss some important terms first. That is, first is your compressibility. So compressibility basically is denoted by beta, and it is inverse of bulk modulus. Bulk modulus is denoted by K. So we know that bulk modulus is change in direct stress to the, it is the ratio of change in direct stress to the volumetric strain with negative sign. It can be written as change in stress delta P, or you can say change in pressure to the volumetric strain delta V upon V, right? Or in differential you can also write it as dP upon dP upon V. So this is your bulk modulus and it is द इनवर्स ऑफ कंप्रेसिबिलिटी. अगर आप कंप्रेसिबिलिटी यहाँ पे लिखोगे तो इसका इनवर्स कर दीजिए तो आपके पास क्या आ जाएगी, कंप्रेसिबिलिटी आ जाएगी. तो वी कैन राइट इट एज माइनस डी वी अपॉन वी डिवाइडेड बाई डी पी. तो दिस इज योर कंप्रेसिबिलिटी. ठीक है, तो नेक्स्ट कंसेप्ट देख लेते हैं हम. दैट इज डेंसिटी इज मास पर यूनिट वॉल्यूम, दैट वी ऑल नोस. आल्सो we have been being uh, we are being learned in previous classes that mass can neither be created nor destroyed, so it is taken as constant. So I can write mass is density into volume. So since mass is constant, take differential on both sides. What will you get? That is dm is equals to rho dv plus v d rho. Since mass is constant, so dm will be 0. I can write rho dv plus v d rho is 0 and divide both side with rho v. So something divided by rho v also 0. Oh sorry, 0 divided by something is always 0. Now in LHS what will you get? You will get dv upon v plus d rho upon rho is equals to 0. So from that you will get the value of dv upon v is equals to minus of d rho upon rho. So this is your second equation and previous one was your first equation, that is this one. So put the value of dv upon v in 1, or you can write beta, that is compressibility here, that is minus dv upon v divided by dp. So put the value of dv upon v in this equation, you will get compressibility in terms of density, that is minus of minus d rho upon rho divided by dp. So this minus minus will become plus. What will you get? You will get d rho upon dp into 1 upon rho. So this is your basically compressibility in terms of density. So from that expression you can have an idea that with change in density, or you can say with change in pressure, density is changing. Okay, I will write it down again here. D rho upon dp 1 upon rho. So from that expression you can say that with change in pressure, density changes. ठीक है, तो अब वाटर के केस में देख लेते हैं हम. वी विल परफॉर्म वन एक्सपेरिमेंट, दैट इज इन केस ऑफ वाटर. सी, वी विल कीप pressure P1 at 1 atmospheric, and it has been found that experimentally that your ρ1 is density at 1 atmospheric pressure is 998 kg per meter cube. ठीक है, although we are taking for the purpose of to solve numerical we take 1000 kg per meter cube. ठीक है, and at pressure of when we increase the pressure to P2 that is 100 atm, the density is increased to 1003 kg per meter cube. So you can say with change in pressure there is slightly increase in density. No? We have increased the pressure up to 100 times. Okay, but the changes in the density is not significant. So if you find the value of beta from this expression, what will you get? Put the value. Rho is basically your original density, मतलब initial density कितनी थी, ρ1, right? So put the value of ρ1 here, 998 into d rho, basically ρ2 minus ρ1 is d rho. Similarly dp is p2 minus p1. So put the value of ρ2 ρ1 and p2 p1, you will get your beta, that is compressibility. ρ2 minus ρ1 is 1003 minus 998 divided by 100 minus 1. So from that you will get 1003 minus 998 is 5 divided by 99. So if you solve this you will get around 5.06 into 10 raised power minus 5, that is your beta. So you can have an idea that is the change in density with increase in pressure is negligible, or you can say it is close to zero. So beta you can say is nearly zero. So in case of water we can write it here that in case of water change in density with increases in pressure is negligible, hence proof. So I hope you like this video and it may help you to solve your numerical problems with this concept, and please don't forget to like and subscribe this channel. Thanks for watching.